Good morning, students. In the last lecture in chapter 2, we have discussed about what is capacitor and what is capacitance. Okay, and we also studied what is parallel plate capacitor. But between two plates, we have assumed insulating medium as vacuum. Now, if that vacuum, which is insulating medium, is replaced by another insulating medium, means dielectric, then what is effect? See, title is Effect of Dielectric on Capacitance. Effect of Dielectric on Capacitance. See, we are taking case 1. Capacitor. One positively charged plate. Surface charge density sigma F. Negatively charged plate. Surface charge density minus sigma F. Between them distance is D. Medium is vacuum. Okay, see, clear each and every term. Two plates, each of area A, separated by distance D. Charge on plates plus or minus Q. On this plus Q, on this minus Q. Charge, free charge density plus or minus sigma F, and sigma F is equal to Q by A. Medium between them is vacuum. Now, yes, one question arises in your mind. Okay, what is sigma F? Free charge density. Because we are free to store any charge on this plate. If you connect battery of different voltages, charges on these plates are also different. So we are free to put charge on these plates, That's why it is called free charge density. Clear? Now we know that in last lecture for parallel plate capacitor we have derived one equation. Okay, between two plates of capacitor, electric field is from positive plate towards negative plate, and E0 is equal to sigma upon epsilon 0. Here I have considered free charge density as sigma F. So electric field between plates E0 is equal to sigma F upon epsilon 0. Why I have used the notation E0? Medium between two plates is vacuum. So E0 is equal to sigma F upon epsilon 0. What is potential difference? If potential difference is V0 is equal to E0D. You know this equation? V0 is equal to E0D. D is distance between two plates. Okay, now what is capacitance in this case? Capacitance in this case, C0 is equal to Q upon V0. And we have derived epsilon 0 A upon D in last lecture. Clear? So see, this case 1 you already know. Case 1 you already know. Now, if this vacuum insulating medium is replaced by another dielectric, then what happens? See, on the plates, charges are due to battery, free charge. Okay, dielectric is placed. Due to charges on plates, means due to free charge, electric field is E0. If dielectric is placed, we know that what is behavior of polar and non-polar dielectric in external electric field. Each and every molecular dipole will align in the direction of electric field. Yes or no? Yes. And in this situation, all charges inside dielectric, they will neutralize each other. Yes or no? Yes, they will neutralize each other. Okay, on a surface near positive plate, on a surface of dielectric, negative charge is induced. Near negative plate of capacitor, on dielectric, positive charge is induced. And we know that these charges are called induced charges or bound charges. That's why its surface charge density is plus sigma B minus sigma B. Remember, this dielectric is of length D and of same cross-sectional area as of plates of capacitor. Okay, so now you know this situation. Sigma F, surface charge density on plates, sigma B, bound charge density in dielectric. Okay, so dielectric inserted between plates. Dielectric is polarized. Each and every dipole align in the direction of electric field. Two charge sheets with bound charge density sigma B and minus sigma B. Yes. Okay. So now, what is total charge density this side? Sigma F minus sigma B. This side minus sigma F plus sigma B. So I can write net surface charge density of plate plus or minus sigma F minus sigma B. Yes or no? Now see here equation. E0 is equal to sigma F upon epsilon 0. This electric field depends on surface charge density. Now net electric field in dielectric E is equal to, what is now net surface charge density? Sigma F minus sigma B upon epsilon 0. Clear? Or what is another method? See, this E0 is electric field due to free charges. Due to these bound charges, another electric field is produced in this opposite direction. Yes or no? And let that electric field E dash is equal to, it is sigma B upon epsilon 0. They both are in opposite direction. So if you take their minus, okay, so you will get sigma F upon epsilon 0 minus sigma B upon epsilon 0. You will get sigma F minus sigma B upon epsilon 0. Clear? Now, potential difference across plate. Hello? V is equal to ED. Electric field changes, potential also changes. So V is equal to ED. See notation. When we have used vacuum, we use notation E0, V0, C0. Okay. Now we are using E, that is in dielectric. When dielectric is placed, potential difference V is equal to ED because E is changed. Sigma F minus sigma B upon epsilon 0 D. Clear? Okay. Now we know that for linear dielectrics, sigma B is proportional to E. That is, this bound charges are due to this electric field. If electric field is strong, then yes, each and every dipoles will align in the direction of electric field. That is called linear dielectrics. So this bound charge density is directly proportional to external electric field. Okay, and external electric field E0, it depends on sigma F. So I can write this as sigma B is proportional to sigma F. Yes or no? Yes. So sigma F minus sigma B, their minus also proportional to sigma F. If we remove proportionality, we have to add some constant, and that constant is 1 upon K, where K is dielectric constant. K is dielectric constant. Okay, you know what is K. So sigma F minus sigma B is equal to sigma F upon K. So in this equation, sigma F minus sigma B, you have to write sigma F. So V is equal to sigma FD epsilon 0 K. Now what is capacitance? C is equal to Q upon V. Hello, charge on plates of capacitor remains same. Charge on plates of capacitor remains same. Here it is Q, here it is also Q. Okay, electric field changes, potential changes, due to that capacitance changes. But on plates, charge remains constant. On plates, charge remains constant. Okay, so C is equal to Q upon V. If you put value of V, that is sigma FD upon epsilon 0 K. Okay, now you know what is value of sigma F? Sigma F is equal to Q upon A. Q cut, you will get C is equal to epsilon 0 K A upon D. Now equation 1, C0 is equal to epsilon 0 A upon D. Equation 2, C is equal to epsilon 0 K A upon D. If you divide these two equations, you will get K is equal to C upon C0. That is, C is equal to C0 K. Yes, in last lecture we have obtained one equation very short. C is equal to C dash is equal to CK. It is similar equation. C is equal to C0 K. C is equal to C0 K. Capacitance increases. If you replace this vacuum by another dielectric constant, because for another insulating medium, for another dielectric, K is greater than 1. For another dielectrics, K is greater than 1. So yes, you will get C is equal to C0 K, means capacitance increases. So what is titles meaning? Effect of dielectric on capacitor. If you replace vacuum by another dielectric medium having dielectric constant K greater than 1, capacitance means capacity to store charge increases. Capacity to store charge increases. Clear? See, some questions based on parallel plate capacitors. Here, exercise 2.5. You are given one capacitor having R as medium. Distance between two plates is D and its capacitance C is equal to 8 picofarad. Now what is question? If distance between two plates is reduced by half, means D by 2, and air is replaced by another dielectric medium having dielectric constant K is equal to 6, then your question is, what is new capacitance? See, for this first capacitor we are assuming data. Let distance between two plates is D, cross sectional area is A, then I can write this C here. C is equal to epsilon 0 A upon D, and is equal to it is 8 picofarad. Any doubt? Now in second case, what is capacitance? C dash is equal to C. There is no air vacuum. Here you are given another dielectric medium, so you have to write epsilon. Cross sectional area remains the same. It is A, but what is distance? Half. It is D by 2. Any doubt? Now this epsilon you can write as epsilon 0. Okay? Yes or no? This A as it is divided by D and this 2 in numerator. Any doubt? Any doubt? Okay. Now we know that epsilon 0 A upon D, epsilon 0 A upon D is equal to 8 picofarad. So how to simplify this? Epsilon 0 A upon D means 8 into what is value of K? It is 6, and here it is 2, and here it is 2. Clear? So you will get your answer. Okay. 8 into 6, 48. 48 into 2. What is 48 into 2? It is 96. So your answer is 96 picofarad, because answer of epsilon 0 A upon D is 8 picofarad. Clear? Okay. So it is very easy. Just you have to understand what is given. Another question. Exercise 2.8. Exercise 2.8. Medium between two plates of parallel plate capacitor is L. Area of each plate 6 into 10 raised to minus 3. D distance 3 millimeter, means I can write 3 into 10 raised to minus 3 meter. See, D is very small than A. You have to find capacitance. What is the equation of capacitance? C is equal to epsilon 0 A upon D. Epsilon, you know what is value? A given, D given. You can easily find. It is your homework. Okay. Second question. If this capacitor is connected with battery having 100 voltage, then what is charge on capacitor? We know one equation, C is equal to Q upon V. So Q is equal to CV. Q is equal to CV. See, here you will obtain. And what is value of V? 100. So you can easily find what is value of charge. Clear? So this question is as your homework. Now, next, last question for today. Exercise 2.28. What is question? In capacitor, we have two plates. You have to prove one equation. Okay? Due to one plate, force acting on another plate. Force acting on another plate. F is equal to half QP, where E is electric field. Where E is electric field between plates. Where E is electric field between plates. Okay, see how to find. First of all, we have two plates. I am taking this plate, first plate. So take this individual plate. What is electric field due to this one plate only? This one plate only. E1 is equal to sigma upon 2 epsilon 0. Quite doubt? Sure, man? Okay. Electric field due to this single plate. I am telling again, single plate. Electric field due to this first plate. E1 is equal to sigma upon 2 epsilon 0. Sigma is equal to Q upon A. We know that. Clear? Now, due to or in electric field of this plate, there is another plate. Yes or no? Having charge minus Q. Having charge minus Q. So force acting on second plate, F is equal to QE1. Here we have to find only magnitude. That's why I am taking only magnitude of charge. Again, here we have to find only magnitude. So I am taking only magnitude of charge. You know this equation, F is equal to QE. Electric field is produced due to this plate. This plate is with the electric field of first plate. So force acting on it, F is equal to QE1. Q as it is. E1 Q upon 2 epsilon 0. Now, what is this E? Electric field between two plates. Electric field between two plates. E is equal to sigma upon epsilon 0 is equal to Q upon A epsilon 0. So, Q A epsilon 0 plus E. You will get F is equal to half QE. You will get half F is equal to half QE, where this E is electric field between two plates. Electric field between two plates. Remember this equation, you can solve MCQs from this equation. F is equal to half QE. Clear? Pause your video, write down from board, make notes and send notes on my WhatsApp number.